Hello. Welcome to More Math Homework Help. All right, so whether you're watching live or whether you're watching the replay, welcome. Here at More Math Homework Help, I'm here to help you solve one problem at a time. So the way it works is you will submit any math homework questions either in a comment or you can submit it on the video, on the form in this video description, and I'm here to help you. So every Wednesday from 8 to 10 p.m. Eastern Standard Time, I am here to help you with your math homework. So to kick things off tonight, I'm going to start with a topic that a lot of students struggle with, and it's also the foundation. In 6th grade, 7th grade, 8th grade, you just keep building on this over and over and over again, and that is combining like terms. So let's do it. All right, so combining like terms, first things first, you got to understand what the word combine means, okay? So combine means add. Combine is just a keyword for adding, okay? So if we break down this topic, combine means add. So we're just going to be adding like terms. Well, okay, what are like terms? First of all, what's a term? So a term is just a part of an expression, right? So here's an expression, x plus 2. That's an expression. And it's an expression because it doesn't have an equal sign. Okay? So x plus 2 is an expression. There's an x and there's a 2 and there's an addition sign. Okay? And so what are my terms? So I split it up. The x is a term. So here are my terms. I have x. And I have 2. So how many terms do I have here? 2. And that's it. So that's a term. Now, what do they mean by like terms? So if I have an expression, let me get rid of this right here. If I have an expression like x, actually, we'll just build off of this, x plus 2 plus 3x. Well, let's split up my terms again. I have x, 2, and 3x. I have 3 terms here. But which ones are like terms? I have x, 2, and 3x. Well, if you just look at this, there are 2 that really stand out. There are 2 that are alike. What do you think that is? Put it in the comments. Let me know. I know you see it. It is x and 3x. Okay, so like terms, as you can see, are terms that have the same variable. Okay, x and 3x, what do they have in common? X. Okay, so let's go back. Combine means add. Terms are each part of the expression. This is called an expression. Why? Because there's no equal sign. And my like terms are terms that have the same variable. Okay, so we have x and 3x. Now, how are we going to combine those? Well, I like to group them in boxes. So I have x and I have 3x. Okay, and 2 is out there by itself, right? Having its own little party. So I put it in its own box. Okay, and I bring that plus sign with me. Plus 2. All right, now let's combine it. I have 1x and I have 3x. All together, how many x's do I have? 4. I have 4 x's in this box. Nothing to combine here, so I bring it down. And that's it. Okay, now I'm sure right now you're saying, that is a very ugly answer. And I know, okay? When it comes to algebra, we get very, very, very ugly answers. So, but this is the answer, 4x plus 2. And that's how you combine like terms. So let's see if we can do another one, okay? All right, 3x plus 4 plus 5x plus 2. First things first, how many terms do we have? Well, let's see. I have 3x, I have 4, I have 5x, and I have 2. 1, 2, 3, 4. I have 4 terms. Okay. What are my like terms? What stands out to you? What looks like similar to each other? 3x, and what else? The only other term that has an x. 5x. I know you said that. But also, is there anything like this 4? Like it doesn't have a variable. It's just 4. 4 is 4. Well, 2. It's by itself too. Okay? 4 and 2 are like terms. So put them in a box. And with this topic, it's really nice to have highlighters or markers because it really helps you keep track of the like terms. So we have 3x plus 5x is what? 3 x's, add 5 x's, I got 8x. All right. Now we have 4 and we have 2. I'm adding them together, and 4 plus 2 is 6. So your answer is 8x plus 6. See how easy that is? Now, what do we call these numbers, right? Because we've done this in elementary school. 1 plus 2 is 3. 4 plus 5 is 9, right? But we never gave names to them. We just called them numbers or whole numbers or things like this. But in an expression, what's its name? What do we call these? We call these numbers constants. And if you think about it, constant means it stays the same. It doesn't change, right? A 4 will always be a 4. A 2 will always be a 2. So it's called a constant because it doesn't change. A 1 is a 1. A 100 is a 100. They won't change. So if there is no variable or letter next to it, it's just going to be the same. And we call it a constant. Okay? And that's why we can combine the constants in this box. Okay, what's this x called? Anybody know? The letter x or y or the first letter of your name, it's called a variable. And if you think of the word vary, V-A-R-Y, it changes. One day x can represent the number 1. One day x could represent the number 45. Another day x could be 100. X changes depending on their mood, depending on the day. Okay, so the variable, it's called a variable because it varies, it changes. It's called a constant because it stays the same. So you want to put your variable with your variable and your constant with your constant. Okay, but what if I have an x and a y? What do I do? Can I combine x's and y's? All right, let's do it. So at any point during this program, if you have any questions, you have your own math homework question, go ahead. You can either put it in the comments or you could submit the form that's in the description of this video. All right, so let's keep going with combining like terms, because this is a very, very, very important part of Algebra 1, Algebra 2, 7th grade math, 8th grade math, and I've even taught it to my 6th graders just recently in the past few weeks. Okay, so now let's take it up a notch. 3x plus 4y, ooh, another variable, plus 2x. All right. Well, Miss Moore, they all have a letter, so can I combine them? All right, well, let's separate our terms. How many terms do we have? I see 3x. I see 4y. And I see 2x. 3 terms. Now, which ones are like terms? They're not all like terms. Otherwise, we could combine them all. So just like before, 3x has an x, 2x has an x, so I can combine those. But what about 4x? 4y, sorry. What about 4y? Unless there's another y, I can't combine it with anything. Okay, so if there was a plus y over here, then yes, I can combine it. But right now, y, it's on its own. All right, so let's combine those x's. I have 3x plus 2x. 3 plus 2 is 5. See how easy that is? And that y goes by itself. Okay, so here's the thing. Math is a language. Once you understand the language, it becomes a lot easier. And here is your answer, 5x plus 4y. Again, the answer looks very ugly, and you're going to be tempted to combine these two terms. You're going to be very, very tempted. I can't tell you how many times I see students do 5x plus 4y and try to combine it and make it look like this. No, don't do it, don't do it, don't do it. Okay, that's it. If I was able to combine them, I wouldn't need these boxes, right? So think of the x like apples and think of the y's like oranges. If I have 5 apples and 4 oranges, do I now have 9 apples if I add them together? No, they're 2 different things. I have to keep them separate. I have 5 apples plus 4 oranges, and that's all I can do with it. Okay, so it's the same thing. You can't combine the apples and the oranges together. This is just your answer. Okay, 5x plus 4y. Okay, and so that's the basis of combining like terms. Okay, well, why do I need to learn that? Because when you get to harder math, like negative 3x plus 2y plus 8 minus 3y plus 5, you're going to wish you understood. Well, now you do, but you got to have that foundation first of understanding what are like terms, what needs to be grouped together so that you can do a problem like this. Okay, so before we even attempt this, what do you see? I see some negatives right here, over here, which makes this a little bit more complicated because you need to understand your integer rules before we attack a problem like this. Okay, so what we're going to do now is go over your integer rules. So once again, as I'm teaching, feel free to put any questions in the comments below or complete the form in the description of this video. All right. So here we go. All right, so I'm just going to keep going with my lessons. All right. So that was combining like terms. If you understood that, if you enjoyed that lesson, give me a thumbs up in the comments if you like. All right. So now we're going to do integers. Let's talk about it. Integers, because I'm going to combine integers with combining like terms soon. So integers. Integers are whole numbers, right? What are whole numbers? Numbers that start with 0, 1, 2, 3, all the way to infinity, right? All those numbers are integers. But what's before 0? -1, -2, -3, and so on, right? All the way to negative infinity. These are what we call integers. Now, when you look at it by itself, you're like, I got this. I know what integers are. Okay, I put a 0 on the number line. To the right of 0, 1, 2, 3, 4, 5. To the left of 0, we have negative 1, 2, 3, 4, 5. Okay, everything is negative over here. All right. So when we look at the number line, it's pretty simple. But here's the thing. Integers by itself, easy, simple. If I teach you adding integers, you're going to be like, Miss Moore. So easy. I teach you subtracting integers, got this. Multiplying and dividing have the same rules. Easy by itself. Here's the issue. Remembering all 3 rules and not confusing them. Okay, so that's what makes integers hard. By itself, adding integers, graphing integers, subtracting integers. By itself, one by one, my students understand it. I'm sure you get it. Very simple. But once you know all of the rules, just like fractions, it's easy to get confused between the rules. Okay? So let's do it. First, we're going to do adding integers. 2 plus -5. Okay, 2 plus -5. All right. First, let me do a diagram because some of you are visual learners. So I like to do a diagram. All right, I got 2 positive chips and 5 negative chips. Oh, that's 4. 5 negative chips. Okay. If I were to add these together, a positive and a negative, 1 positive chip and 1 negative chip, if I put them together, what does that equal? 1 positive chip and 1 negative chip together, they cancel each other out. Okay, think about it this way. If I go up the elevator, I go up 1 floor and I go down 1 floor, what happened? I'm still at 0. I didn't go anywhere, right? If I move 1 step forward and take 1 step back, I'm where I started, right? So it cancels each other out. 1 positive and 1 negative, we call it a 0 pair. It's 0. Another positive and negative, 0. So what am I left with? 3, that was an ugly circle. I'm left with 3 negatives. And here we go, -3. Okay, and that's that. So let's do it again. 2 plus 5. So now we just did 2 plus -5. Obviously, we know 2 plus 5, right? Hopefully, is 7. Okay, but again, using the chips, we have 2 positive chips, 5 positive chips. The positives don't cancel each other out. So all together, 1, 2, 3, 4, 5, 6, 7. Easy peasy. Now, what if this was negative? What if this one was negative? Negative 2 plus 5. Let's do it. What do we see? Once again, we can cancel it out, these 0 pairs, and we are left with how many positives? 1, 2, 3. Our answer is positive. When we had 2 plus negative 5, our answer was negative 3. When we had 2 plus 5, our answer is 7. When we have negative 2 plus 5, our answer is 3. Let's see if there's a pattern going on here. Okay. I'm going to write that back. Okay, and now we have negative 2 plus negative 5. Okay, we put the parentheses here just so that you don't get confused with the plus sign and the negative. Okay, so we have 2 negatives and 5 negatives. Okay, how many negative chips do we have altogether? 1, 2, 3, 4, 5, 6, 7, and it's negative 7. All right, so let's do it. Let's see if there's a pattern. 2 plus 5 is 7. Negative 2 plus negative 5 is negative 7. 2 plus negative 5 is negative 3. Negative 2 plus 5 is positive 3. Okay, so what do you notice? When I have 2 positives, my answer is positive. When I have 2 negatives, my answer is negative. But when I have a positive and a negative, sometimes it's negative and sometimes it's positive. Okay, so let's focus on this for right now because this is the easiest, right? Same signs. So when I have the same signs, right? 2 positives, 2 negatives, what do? Well, I just add them together and my sign stays the same. Okay, same sign, add them together and keep the sign the same. All right. So that's when we have the same sign. All right. I see that, right? 3 plus 4 is 7. 5 plus 5 is 10, right? Negative 5 plus negative 5, I would have 10 negative chips, right? 8 plus 5, 13, you get it. All right. What about different signs? So when I have the same sign, add them together and my sign stays the same. But when I have different signs, what do you notice? Because 2 plus 5 is 7. So how did we get 3? And negative 2 plus 5 is 3. So what does it look like we are doing here? What does it look like we're doing? I know you said it. Subtracting. Okay, so when the signs are different, we are subtracting. Okay, so we did 5 minus 2, and we got 3. Okay? For both of these, it was 5 minus 2. But why was one negative and why was one positive? Okay, so my students like to say, whatever the bigger number is, that is the sign of the answer. So they say, well, -5 is the bigger number, so my answer is going to be -3. Or 5 is the bigger number, so my answer is going to be +3. Okay, if that helps you remember it, great. However, this negative number will never be bigger than a positive number. Okay, so if we're thinking about it mathematically, a negative will never be bigger than a positive. Okay, so if it's negative, think about a tug of war. Okay, so we have the negative side and we have the positive side. Okay, so if I'm at 2 and I add a -5, okay, I'm pulling that rope to the left, okay? So when I add a negative number, I go to the left 5 spaces. 1, 2, 3, 4, and 5. I'm pulling it more toward the negative side, okay? And so my answer comes out negative. Okay, but if we were going to start at -2, just like here, and add 5, I'm adding 5, which means I'm pulling it in the positive direction. So let's go that way. 1, 2, 3, 4, and 5. 3. Okay, so that's how we got 3 for this one. And this is how we got -3 for that one. Okay, so when I add a negative number to something, I'm pulling it in the negative direction to the left. Okay, and when I add a positive number, I'm pulling it to the right. Okay, so that's adding and subtracting. One more time. So I want you to do this on your own. 4 plus -2. Okay? 4 plus -2. Remember, when we have the same sign, we add it together and we keep the same sign. Okay? And when we have different signs, we subtract. So do we have the same sign here or do we have different signs? We have different signs. So we're going to subtract and take a look at what we're adding. We are adding a negative number. So it's going to be pulled to the left in a negative direction. Okay, so instead of going 4 and then to the right to 5 and 6, because we're adding a negative number, what's the answer going to be? Four minus 2, we know to subtract is 2. Okay, but is it +2 or is it -2? It's +2 because we're just going to the left 2 spaces. And that is adding and subtracting integers. All right. Awesome job, guys. All right, so we're going to take a quick break. If you have any comments or questions, go ahead and put them in the comments below. And if you have any homework questions, go ahead and submit them by completing the form in the description. Okay. All right, and we're back. Great information. I love your presentation style. Yes, absolutely. It will be the replay will be live after this live. Thank you, Misha. Appreciate it. All right. So right now what we're going to do is combine both, okay? So we did adding integers, and we did combining like terms. Now we're going to add negative and positive terms. Let's see. All right. So negative 2x plus 5 plus 3x minus 6. All right. So here we go. Remember, we separate our terms. So how many terms do we have? I see a negative 2x. I see a 5, a 3x, and a negative 6. 4 terms. And which of my terms are alike? Okay, so we're getting into 7th grade math here. Before we were at 6th grade math, all positive numbers. We're happy. Now we're getting into 7th grade math, right? We got some negatives, we got some positives. It's just like the 7th grade life, right? Some ups, some downs. We're the middle child. We're okay. So here we go. I've got negative 2x. And I have plus 3x. Put them in a box because they both have x's. All right. Negative 2x plus 3x. All right. So I have negative 2 plus 3. Okay. We know it's going to end up being x's, right? So you're really looking at negative 2 plus 3. Okay, you could either use the number line or you can use your chips. Okay, and I was using pink for my negative chips. So let's keep that the same. And I was using yellow for my positive chips. So I have 1, 2, 3. All right, so what happens to the negative chip and the positive chip when they come together? They're a 0 pair. They cancel each other out. Okay, so how many 0 pairs do we have? 1, 2, cancels each other out, and I'm left with just one positive chip, or just one x. So you can leave it as just x, or you can make it 1x. It's really up to you, but a lot of times we just write 1x as x, because there's only one of them. Okay. Next, we have, what do we have left? A 5. Here are constants, because a 5 is just going to be a 5. And we have a -6. Okay. And I know some of you are saying, but Miss Moore, that's a minus sign. Yes, it is. But when we start to do expressions, we look at subtraction as a negative. Okay. So when we split the terms and we draw that line, this is now a -6. Okay. So now put it in a box of its own. Oops, sorry. All right. So we have 5 and we have that -6. Remember, combine means to add. So let's go over here. 5 plus -6. Once again, if you like those chips, we got 5 positive chips. And we have 6 negative chips. Okay, so my visual learners, I hope this is helping. And look at what we have here. We have a 0 pair. They cancel each other out. Positive and negative chips cancel each other out. And we're left with 1 negative chip. So this is a -1. And here's my answer. Okay. Thanks, Matthew. So your answer is X minus, oh no. I'm so sorry. Thank you for saying that. Uh-oh. Okay. Thank you for saying that. All right. So then your answer is X minus 1. Okay. Let's do a different problem now that you can see my screen. Okay. So let's put those negatives back in there. Thank you for saying that. All right. So here we go. 4x. And I probably should stop using x so much. Let's use y this time. -4y plus 6m plus 3y minus 2m. Okay, so let's separate these terms. 1, 2, 3. We have 1, 2, 3, 4. Here are our terms. Always write down your terms. We have -4y. We have 6m. We have 3y. And we have -2m. Okay? We look at this minus as a negative. All right. So, what are my like terms? Which terms have the same variable or the same letter next to it? Well, I see a y over here. And are there any other y's? Yes, there is, right here. Bam. Okay, so now combine them. Put them in their own little neat box. -4y plus 3y. All right. So we know there's a bunch of y's in here. So my answer is going to come out y. But what about these? I have a -4 plus 3. So if you have 4 negative chips, 1, 2, 3, and 4, and 3 positive chips, 1, 2, sorry, y'all. I mixed them up. Okay, so I know I was using positives as yellow, so I don't want to confuse you. All right, so you have 4 negative chips. Let's do that again. 1, 2, 3, 4. And you have 3 positive chips. 1, 2, and 3. All right, first things first, we cross off our 0 pair. My negative and positive chips, they cancel each other out. 1, 2, and 3. Okay? And I'm left with a -1. Okay, so you can write it as -1y or just -y. It's really up to you. Both are the same thing. Most of the time you will just see -y, but it's the same exact thing. And the reason why is because 1 times y is just y. So that's why they kind of just leave it as -y. Okay, so if you've seen that before and you weren't sure about why it just said y and not 1y, it's the same exact thing. Y just looks prettier, so that's why they take out the 1. But if you like seeing it there, leave it. All right, so we have 6m and -2m. Okay. These are m boxes. So I'm going to have an m when I finish. So let's take care of these numbers. We have a positive 6, okay, plus a -2. Once again, draw your chips. We have 6 chips. Oops. And positive chips and 2 negative chips. How many 0 pairs am I going to have? And after a while, you won't even need to draw these chips, because after a while, you'll be like, oh, I got it. I'm really subtracting because they're different signs. And I'm left with 4 positive chips. Okay, so this is going to be 4m. So you could either write it this way, -1y plus 4m, or -y plus 4m. Both of these answers are correct. They're ugly, but that's it. Okay, so that is your answer. So when you're simplifying expressions or combining like terms, this is all we do. We color code it. We make it easy for us to see our like terms. We group it in boxes. We put our integer rules that we talked about earlier, adding integers. We draw our chips, or we think about when I have different signs, I subtract, however you want to think about it. But that's going to help us get to our final answer. Okay? Awesome. Great job. Any questions in the comments? So this is our first ever homework help. I know a lot of people are on spring break this week, and I'm going on spring break next week. So I'm excited about that. But probably in a couple of weeks, things will pick up because everybody's back in school. But again, if anybody has any questions that they want to go over, anything they're just not sure about, I'm available for you. Let me know. You guys are helping me record some videos that I can post later on. So this is helpful either way. All right. Let me hide this ticker. All right, there we go. Any topics that you guys want me to go over? Because I'll just keep going with what I have planned. But any topics that you feel like your child might struggle with, that you want me to kind of go over, let me know that as well. And I can tackle those problems, okay? All right. And let me keep sharing my screen. Okay, I'll be waiting for your comments as oh no, what just happened? Sorry, guys. Share screen. Okay. There it is. Here's a scary word. Everybody hates these. Fractions. And you know the thing about fractions, once you're introduced to them, they just never go away. As much as you want fractions to go away, they never do. You see them in elementary school, you see them in 6th grade, 7th grade, they start adding a negative to the fractions. 8th grade, they start adding variables to the fraction. It just never disappears. You're going to be seeing fractions all the way through college math. So you could either let it scare you or you can master it, okay? And that's what I'm here for, okay? We're more math. here helping you solve one problem at a time. So let's talk about fractions. First things first, adding fractions. Okay, so again, so with fractions, just like integers and all these things, decimals, there's so many rules. Okay, again, by itself, you're able to do it, right? If I taught you how to add fractions, you're going to be able to add fractions. No problem. If I teach you how to subtract fractions, fine. Multiply, divide, all of that. By itself, you can do it, right? But all of a sudden, your mind is filled with so many rules that now I'm confusing them. Okay, so now I go to multiply fractions and I'm trying to find common denominators, right? Or I go to divide and I'm trying to multiply or divide straight across, right? So there's so many different rules. I know, I get it, okay? The biggest thing that's gonna help, honestly, is to just keep practicing them over and over and over, okay? In my class, I have something called an interactive notebook, and you've probably seen them, but they have foldables. It's almost like a cheat sheet. And the more you use those foldables that have the rules, the more they're going to help you, and those rules will really stick. So I'm going to teach you each operation. However, you're just going to need to practice them over and over and over again so that those rules can stick for you and you're able to conquer fractions, okay? So let's start with adding fractions. So we have 3/5 plus 2/7. Okay. Most people teach you, so most of you are middle school, high school, right? At this point, if you are struggling with fractions, I'm sure a lot of your teachers have taught you to just multiply the denominators together to find a common denominator. You can absolutely do that, okay? If you want to learn how to find a common denominator, how most people, how you did it in elementary school, I'm going to show that to you right now. Okay, so we have 5 and we have 7. Okay, so we find the least common multiple. And that sounds really complicated, I know, but watch this. You're just counting by that number, okay? So you're just counting by the number, 5, 10, 15, 20, and so on, right? 7, 14, 21, and so on. Now, in this case, 35 is going to be your least common multiple. But if you have bigger fractions, sometimes you're not going to want to multiply them together. There might be a smaller multiple that is easy for you to work with. So I do want you to kind of understand that you're just counting by both of those numbers until you get to something that they have in common, right? So if it was a 2 and an 8, right, you would count 2, 4, 6, and here you would go 2, 4, 6, 8. Here you would go 8, 16. But right away you would see that they have 8 in common. But if you were to multiply them together, you would get 16. But 8 is a better denominator, and you'll see soon why, because it's less reducing at the end, okay? So I want you to learn both ways because it can help you at the end with solving it to make less mistakes, okay? So, but for this one, either way we do it, we're gonna get 35 as a common denominator. All right, so line them up vertically. 3/5 plus 2/7. All right, so our common denominator that we said is 35. Now here's the thing. I need to keep my fraction balanced, okay? If I do something to this denominator, I'm going to need to do something to this numerator to keep it the same, okay? This fraction, 3/5, should equal this fraction on the right. They got to stay the same. So I got to keep it balanced. So 5 times what is 35? 7. So if I multiply the bottom by 7, whatever I do to the bottom, I got to do to the top. So 3 times 7 is 21. Okay? Now we do the same thing. Again, we have 35 as our common denominator. 7 times what is 35? 5. And whatever I do to the bottom, I have to do to the top. So 2 times 5 is 10. Okay? Are we done? No, because I haven't added anything. Okay? That's the other thing with fractions. You go through all this work and you're like, okay, I've had enough. I did all the work. I'm done. And there's always more. I don't know why. But yes, we found a common denominator, but we have not added anything. So let's add it together. 21 plus 10 is 31. And our answer is 31/35. Okay? Easy, simple. Okay? So now let's do another one because practice makes perfect. All right. So we have 3/4 plus 5/8. So here's one of those examples. Let's say you want to do 4 times 8, right? And to get 32 as your denominator. So I just want to show you how much more complicated it is to multiply them together than to just find a smaller common denominator. So watch this. So you multiply together and you say, oh, okay, 4 times 8 is 32. Okay? That's going to be your common denominator. Again, you can absolutely use this if this works for you. However, I'm just going to show you how to make your life a little bit simpler. Okay, so 8 times 4 is 32. Whatever I do to the bottom, I have to do to the top to keep it the same. So 5 times 4 is 20. Okay, let's do the next one. 4 times 8 is 32. So whatever I do to the bottom, I do to the top. 3 times 8 is 24. All right? And now add them all together. 24 plus 20 is 44 over 32. Uh-oh. Now I have an improper, now I have an improper fraction. Okay. 44 over 32. How do we find that mixed number? Well, we put the numerator in the house. This is what I teach my students. You put this numerator and we call this a house. Okay? 32 goes into 44 one time. Okay, we got some long division here. And I take my remainder and I make it into a fraction, 12 over 32. But I'm not done because I need to do more simplifying. I need to do more reducing. And this is when it starts to get a little bit more complicated. Okay, your final answer is going to be 1 and 6 over, nope, 4 goes into both of these. 1 and 3 over 8. Okay, 1 and 3/8. Okay, but let me show you how to get it a little bit simpler. All right, so let's take the same problem. 3/4 plus 5/8. All right. I'm going to erase this just so you're not distracted by all of this. All right. 3/4 plus 5/8. Now, remember what I taught you before. Just count by those numbers. I have a 4 as the denominator. I have an 8 as the denominator. I'm just going to count by those numbers until I get to something that I have in common, right? Oh, I can stop right here. They both have an 8. So 8 is my common denominator, all right? I'm going to move this over here and use a different color. All right. So I have 3/4 plus 5/8. All right, so 8 is my common denominator. 8 is going to be my common denominator. Well, let's start with the obvious first, right? 8 times what is 8? 1. So 5 times 1 is 5. This stays the same. It's already an 8. Okay, 4 times 2 is 8. And 3 times 2 and 6. Okay, now 6 plus 5 is 11. So we didn't get out of having a improper fraction, which is fine. And let me just remind you of our original answer, 1 and 12 over 32. Okay, but watch this. Put that numerator in the house. Okay. 8 goes into 11 how many times? Once. 1 times 8 is 8. Take your remainder and make it a numerator, and that 8 is still the denominator. So I have 1 and 3/8. I don't have to do anything else. I'm done. Okay? But with that other one, okay, you added it together, you found the common denominator, you divided, and you still had more work to do. Watch this. What number can go into both of these? Okay, you might be saying 2, which is fine. You just have to keep dividing until you can't divide anymore. But a bigger number can go into both of these, 4. Okay, so eventually, depending on what you divided by, you're going to get 1 and 3/8. Okay, you just get there a little bit faster with actually taking time to find the common multiple, and it doesn't take you that long. Again, you just count by that number. Okay, so a lot of times you are going to have to do like it may be a shortcut to finding a common denominator, but it may end up being more trouble at the end because now you have to simplify. Okay, which is going to leave you more room for error when you simplify. So again, I prefer that you just learn how to find the least common multiple and do it that way because it'll make your life a whole lot easier. But if you like just multiplying it together and that works for you, listen, I'm fine with that, okay? Do what works for you, okay? When it comes to math, my rule is this, okay? Whatever helps you get the right answer, do it that way. Math is not stagnant, okay? Math is not one-dimensional, okay? So whatever is going to help you get to the right answer and you're able to get to the right answer every time, go with that, okay? I am absolutely fine with that, okay? And hopefully your math teacher is as well, okay? As long as you're able to explain your work and, help them understand what you did, you're good to go, okay? You can do math your own way. So I just always like to show you an alternative way, but if your way works or you have a teacher or a parent that showed you a better way of doing it that works for you, do it that way, okay? All right, hey, Anish. All right, so let's do it again. All right, let's see how you do with this. So we have, keep using 3s, but it'll work. 3/10 and 6/15. 3/10 and 6/15. Let's find a common denominator. So once again, you can multiply these together, right? And get 150. Sure, fine. Or watch this. There's an even smaller number here. Count by 15. 15, 30. Okay. Count by 10. 10, 20, 30. What do we notice? And this is a whole lot smaller than 150. It's a lot smaller, which means we're going to have less reducing at the end. Yay! Okay, so let's do 310 plus 6 over 15. All right. So 30 is my common denominator. Woohoo! Okay. So 15 times what is 30? 2. And 6 times 2 is 12. Easy peasy. 10 times what is 30? 3. And 3 times 3 is 9. All right. So now add them together. 9 plus 12 is 21 out of 30. Okay. We are going to need to reduce because I see a number that can go into both. Okay. 3. 3 can go into both. And 21 divided by 3 is 7. 30 divided by 3 is 10. Okay, which is fine. Now, let's say that you multiplied the denominators together. Okay, and you got 150 here and 150 here. Okay, 10 times 15 is 150. Okay, 3 times 15, 45. You knew that. I know. 15 times 10 is 150. And 6 times 10 is 60. We have some big numbers to work with, meaning at the end, you're going to have a lot to reduce. But if you like it that way, go for it. Okay? When you add your numerators, you get this big number. You've got a lot of reducing to do because you need to make it all the way back down to 7/10. Do you see how much easier it was to reduce this than to try to reduce this over here? It's a lot. Okay? It's a whole lot. So you're going to want to, like I said, if this works for you, I love this way for you to just count and find the numbers they have in common and then do it this way, as opposed to, doing a shortcut, multiplying the denominators, but at the end, it turns out it's not really a shortcut because you have so much simplifying to do, okay? So much reducing to do that it's crazy, okay? So again, learn how to find your multiples because it can really help you save time, all right? So that is adding fractions, and subtracting is absolutely the same way. Welcome, guys. So to all my people that just showed up, hello. This is More Math Homework Help. Okay, if you have any questions, you can just put it in the comments, or you can submit your questions on the form in the description of this video. Okay, so if you have any homework questions that you need help with, you can post it right there in the comments. But if you want to be anonymous, you can just fill out that form with your question and we're good to go. All right. Any comments? Any notes? Feedback? Are y'all enjoying this? All right. I've been talking about making a YouTube channel for a while now, so y'all are helping me out. Take that big leap. Okay, so here we go. So we just finished talking about adding fractions. subtracting fractions is the same exact way, okay? So I'm just going to jump right in here and help you out with subtracting fractions. All right, so we have 4/5 minus 1/9. Okay, in this example, when it's smaller numbers, yes, it's easier to just do the multiplying the denominators together. However, so in this example, yeah, you are going to end up with 45 as your common denominator. I can't even, oh, there it goes. I was like, what's 9 times 4? Okay, so in this example, what they both have in common is 45. You know, anything that ends in a 5 and 0 goes into 5. So it's going to be 45. Okay, so sometimes you won't have a choice of a different denominator, but when you do, if there's a chance that it's a smaller number, I would try this out. Okay, so we got 45, 45, and let's keep it going. 9 times what is 45? 5. So whatever we do to the bottom, we do to the top. So 1 times 5 is 5. All right. 5 times 9 is 45. So 4 times 9, keep it the same. 4 times 9 is 36. We are subtracting here. So 36 minus 5. We always keep that denominator the same. Okay, so we're just doing 36 minus 5, and our answer is 31 over 45. Now, can we reduce this? No. So we are done. Okay, so something about fractions and combining like terms. We did combining like terms earlier. The answers, they just look ugly. Okay, I think a lot of students struggle with fractions because, you know, they don't look very pretty, right? Our answer's ugly, 31 over 45. You're like, isn't there more to do to make it prettier? Like, can't we make it like 1 or 2, right? Same thing with the expressions that we did earlier. We keep wanting to make it into one pretty answer. We're like, that can't be the answer. That just looks so weird, right? But that's the answer. All right, so that's subtracting fractions. All right, we're going to take one quick break. All right, once again, if you have any homework questions that you need help with, let me know. I'm here for you. We're going to take a quick break and be right back. All right, welcome back. Okay, so once again, welcome to More Math Homework Help. I'm so glad that you are here, whether you're watching live or whether you're watching the replay. I hope this is helpful. Remember, every Wednesday night from 8 to 10 p.m. Eastern Standard Time, I am here for you to help you with your math homework, one problem at a time. Okay, so again, if you have any questions as you're watching this, you can put them in the comments, or if you want to remain anonymous, you can fill out the form that's in the description of this video, and I will be happy to help you with your homework. If there's no questions, as I've been doing, I will just keep teaching. Okay, so I'll poll the audience. Is there any questions or topics that you know maybe you struggle with, or a student you know or a child you know struggles with? Let me know in the comments. Okay, so if there's a topic that you are like, you know what, my child struggles really with this, right? So fractions were a big one, so that's why we did adding fractions and subtracting fractions. But if there's anything else that you know your child struggles with, or you yourself struggle with when it comes to math, let me know. Oh, yes, go ahead. Algebra. I love algebra. So you can go ahead and type it. And you know, algebra is a language in and of itself. No more numbers. It's all about X and Y. So in terms of like when we were, like solving an equation. So like, give me an example, like if we were doing X plus 4 equals 6, or do you want both of them to have like an X on both sides? Because there's so many equations. Or like we were doing before, where it was like 3x minus 5 plus 2x minus 1. Let me know which one you prefer. Okay, so this one, the second one I gave you, is an expression because it doesn't have an equal sign. The top one is an equation because it does have an equal sign. So just let me know. Okay, perfect. X on both sides. So let's do it. So this actually goes back to what we were doing before with combining like terms. So I told you guys, and if you missed that part, that's fine. This will be up for the replay afterwards. So what we always do, that equal sign, think about a scale. So I'm going to remove this first. Okay, so think about a scale, right? If I do something to the right side, right now it's equal. If I add something to this side, my scale's going to tip like this, right? What do I have to do to this side to keep it balanced? I have to, whatever I did to this side to bring it down, I have to do the same thing to this side to make it balanced. So when you see an equal sign, that means that whatever's on the left side of the equation is balanced or equal to what's on the right side. Okay, so whatever we do to one side, we have to do to the other side to keep it balanced. That is a huge part of this. Okay, so now let's go. All right, so first we need to identify our like terms. I cannot combine an X with just a number. So I can't combine 2x with 4. They are not like terms. Okay, so 2x can, however, be combined with x because they have the same letter. All right, so I'm going to move. I got to get my x's together on one side, and I have to get my numbers on the other side. That's the goal right now, okay? Because I want to know at the end, my answer is going to say x equals something. By the end, I want to have x equals something. That means I need to get all of my x's to the left and all of my numbers to the right. Okay, well, how do I remove this? I have a plus x right here. How do I get rid of the plus x? I have to do the opposite. So to get rid of addition, I have to subtract. So I'm going to subtract x. And whatever I do to the right, I do to the left. All right. So I have two x's and I take one x away. How much do I have left? One x. Okay, so earlier I explained that one x and x are the same thing. It's up to you how you want to write it. Okay, most of the time you will see it written as x, but if you like to write it as 1x and that helps you, go ahead and do that. Okay, whatever works for you. So, but we're left with x on this side. A plus x and a minus x, opposites cancel each other out. Okay, now I got all of my x's to one side. Great. All right, so just bring this down. X plus 4 equals 6. All right, now what? Well, I have my x's on the left side, but I still have this 4 here. It's getting in the way. I need to get rid of that. Okay, so again, I have to get rid of addition and I need to get rid of this 4. How do I do that? I'm going to subtract the opposite of addition, 4, and whatever I do to the left side, if I take away 4 on the left side, I have to take away 4 on the right side to keep it balanced. Okay, so these 4's cancel out. I'm going to bring down my x, which is right here, and 6 minus 4 is 2. And this is what we call a multi-step equation, okay? Because there are a lot of steps. I had to move all of my x's to one side. I had to move all of my numbers to the other side. And then I had to solve for x, okay? So let's do another one. Did that help, Robin? Okay, so we get x equals 2. Okay, I'm going to do another one, this time with different numbers. So 4x minus 5 equals negative 6x plus 2. Okay, so we have 4x minus 5 equals negative 6x plus 2. Okay, you said I had a light bulb. That's the point. Yes! Woo! I love the light bulb moments. Okay, so you took x away from the right side first, and I never thought of that being possible. So I was all focused on trying to take away the 2x from x. Yeah, so you can absolutely take away the 2x from x, but it's going to look really strange, right? So my rule is always take away the smaller, move the smaller number over. One, because you avoid all the negative numbers and the positive stuff. And it just helps out a lot more. Okay, so let's do it. Okay, so similarly, we're going to start with the x's. We have 4x and a negative 6x. Okay, again, I like to move the smaller number, and in this case, a negative is going to be the smaller number. What is the opposite of a negative? A positive. Okay, this is how I'm going to get rid of the negative 6. Okay, negative 6x. I'm going to add a positive 6x. And do you see how adding that positive 6x, I'm not working with negatives. I only have a positive 10x. Okay, and I get rid of this negative 6x. So now I don't have to worry about negatives anymore. I don't have to worry about any negatives, which I'm happy about. Okay, so now I have the x on the left. Now what's the opposite of minus 5 plus 5? Okay, we have 10x. Cross that out, they cancel out, equals 7. All right, now this is going to look really ugly. I'm not even going to lie to you, it's going to look ugly. But, all right, so now we have 10x equals 7. 10 times x, this is what I teach my students. 10x is really 10 times x, and I teach them side by side, we multiply. Okay, side by side, we multiply. So when you have the 10 and the x, that is really multiplication. So to get rid of this x, I have to do the opposite of multiplication, which is division. Okay, and I have to divide by 10 because that's what I want to get rid of. And 10 divided by 10, bam, got rid of it. 10 divided by 10 is 1. You can put 1x or you can just put x, okay? And I have a fraction. Don't try to divide this. Leave it as a fraction, okay? Unless they want a decimal or something, which they probably don't. Don't make your life more complicated. Leave it as a fraction. Keep it simple, okay? So then it would be x equals 7/10, okay? If you have another problem that you've been struggling with, just put it in the comments so that I can help you out, or let me know if you want me to keep going with problems like this, if that is helpful for you. Like if you prefer like more negatives in there or whatever, okay? I'm here to help. I just realized that ticker was, okay. Let me check the comments. Yay, I love this. And the one thing you said, which is the purpose of me doing this whole thing, math homework help, is that light bulb moment. That is like the best feeling as a teacher, helping it all click. I love it. Okay. I'm going to do more because I have my students watching and I know they're like, oh my gosh, I haven't learned this yet. Let's do y's now just because. Okay, so let's say actually there's x and y. We have negative 5y minus 2x. And on the other side, we have 3x plus 6y. All right, so what do we do? Oh, thank you. I'm so glad it's easier. All right, so as I said before, I always like to put the smaller number, move the smaller number. But if you look at the x's, you have a negative x, 2x on this side, but you also have a negative 5x on this side, right? So at some point, you're going to have to work with a negative. I choose the bigger negative to move. That way, I'm just working with smaller negatives, okay? But you can move any one you want, okay? So the opposite of negative 5y is a plus 5y. So I'm going to add 5y to the left, and whatever I do to the left, I do to the right. Okay? Negative 5y plus 5y cancels out. I have a negative 2x equals 3x, and 6y plus 5y is 11y, right? Now, let's move all my x's over. Okay, how do I get rid of this 3x? Subtract 3x from both sides. All right, so I have 11y on this side. Negative 2 plus negative 3 or minus 3. Negative 2 minus 3. So earlier we talked about integer rules, okay? Now we didn't get to subtraction, but we do something called keep, change, change. We keep that first number the same. We change subtraction to addition. And we change 3 to its opposite. So keep this the same. Negative 2 stays the same. We change the subtraction to addition, and we change the 3 to its opposite. Okay, so it's really negative 2 plus negative 3. And as we talked about before, when we add the same sign, we add the numbers together and we keep the sign the same. Okay, my goal is always to figure out what does x equal. So I'm not done. Okay, so it's going to look super ugly because we have two variables in the answer. Okay, so I got to get rid of this negative 5. It's still attached to x. Negative 5x is negative 5 times x. I got to divide. So I'm going to divide both sides by negative 5. I'm left with x on the left. And this is super ugly, okay? I just made this up off the top of my head, and you can just leave it like that. Most of the time, x equals a number, but I just made this up, so I just made it up, but that's how you would solve it. So sometimes you'll have two smaller numbers on one side, like we did over here. They both were negatives, so you couldn't avoid having to do integer rules. You just had to do them, okay? But it's easier to do negative 2 plus negative 3 than it would have been to do negative 5 plus negative 6, right? So it just makes your life a little bit easier, okay? Yay, I'm so glad that helped. Anybody else have a homework question? Robin, I can keep going with you. So don't feel like you only have to ask one question. If there's anything else that you get confused with, let me know. I'm here for you. We got 30 minutes left. All right. So for those who just joined us, welcome to more math homework help. All right. If you have any questions, any homework question, anything that you're struggling with in math class, put it in the description. Put it in the comments. Or if you want to remain anonymous, but you really are struggling with something, go ahead and fill out the form that's in the description of this video, and I can help you out. Okay. Awesome. So we have Anish said, can we do 2x plus 3? Minus 3. So here we have expressions. Here we have expressions. So this was a current topic I did with my students. Okay, and the reason this is called an expression is because there's no equal sign. Okay, so at the beginning of this, closer to 8 o'clock, the beginning of this video, we talked about combining like terms. Okay, so first things first, we need to identify the like terms. But before we can do that, oh, I have this weird thing right here. Okay, what do I do? Right? So this is what we call the distributive property. So remember when we had 2x and I taught you guys that side by side we multiply? When we have two numbers or variables next to each other, that's multiplication, okay? That's multiplication. 3 parentheses 2 is multiplication, right? If both of them are in parentheses, that's multiplication as well. Now let me just move that out the way. Okay, so side by side, we multiply. Okay, so if both are in parentheses, that is also multiplication. So in math, there's like 50 million ways to show multiplication. After elementary school, they stopped using an X because now, as you can see in this problem, X represents a letter, a variable, right? So we can no longer use X for multiplication because it's real confusing. Okay, so -3. So remember I told you we have to look at subtraction now as negatives. All right, so this is a -3, and we do the distributive property. The distributive property, I have a 3 next to parentheses, just like over here. This is multiplication. Okay, this is multiplication. So side by side, we multiply. This means that -3 is going to be multiplied by everything in the parentheses. Everything in the parentheses gets multiplied by -3. So let's do it. -3 times 4x is -12x. -3 times 7, -21. Okay, now let's bring everything else down. We have a 2x plus 3 minus 12x minus 21. Okay, so as I showed you guys at the beginning of this video, we separate our terms. We have 1, 2, 3, 4 terms. Now, combine your like terms. Which terms are alike? 2x. And what else has an x? -12x. Put it in a box. This is the X box. Oh, X box. So you have 2x and plus -12x. Remember, combining like terms means to add them together. So x is going to come out of this box. 2, and let me move this up. Okay, so 2 plus -12. Okay, so you were getting 14x. However, this is a +2 plus a -12. You have to subtract these two. So -12 plus 2, 12 minus 2 is 10. Okay, it's going to be a -10. We're starting at -2 on the number line, and we're going forward 2 spaces. We're adding 2 to it. So it's going to be a -10. Sorry. Okay, so I get a -10x. Awesome. Now, what do I have left? 3 and -21. They go in a box together. Okay, you said you got a 10 here. You see it? Okay, good. I was wondering if you mixed both of them up. Yeah, -18. Okay, good. So it's a -10x minus 18. Did you mix up the let's see. I'm trying to figure out what you might have done to get the 14. Oh, I see. You did 3 times 4x, which is 12x. You forgot about the negative. That's what happened. Okay, so just be careful. You have to look at this. I know it's hard, but you have to look at that as a -3. Okay, so that actually is a -3, because if you just looked at it as 3, I could absolutely see how you got a 14x here because it would have been a 12x plus 2x, right? The 10x, oh, I know what you did with the 10, right? You forgot to multiply the negative 3 by 7, okay? Because even if you did 3 times 7, you would have gotten 24, but you forgot that you were supposed to multiply everything in the parentheses by that 3. But good, okay? Let's see. Keep these questions coming, guys. I'm going to do one more with you, Anish, to make sure you really got it. Okay, but if you guys have questions, go ahead and put them in the comments. Thanks for sending your sister, Anish. Geometry is not my forte, but I can try. See what I do. See what I can do. All right, so we have, let's do some distributive properties. So we have 3 times 2x minus 1 minus 2 times 4x plus 4. Okay. So again, side by side, we multiply. 3 times everything in the parentheses. And also, we got to multiply twice because look, I have to do negative 2 times everything in the parentheses. Don't y'all love algebra? Okay, so I got to do 3 times 2x, okay, which is 6x. I have to do 3 times negative 1, okay, here it is right there. 3 times negative 1, which is a negative 3. So over here, I have a 6x minus 3. Okay. What do I have over here? Negative 2 times everything in the parentheses. So negative 2 times 4x is a negative 8x. Negative 2 times 4. Don't forget about that. Okay, when you have your answer, you can put it in the comments. Okay, I'm going slow so you have time to do it. Okay, negative 2 times 4 is a negative 8. So we have minus 8x minus 8. Okay, we're not done because we need to combine our like terms. Okay, so separate your terms. I see 6x and negative 8x. Okay, those are the only ones with x's. So let's put it in a box. And then I have negative 3 and negative 8. Okay, combine your like terms. So let's go to the box that has the x. 6 plus negative 8. They have different signs, so I'm going to subtract. 8 minus 6 is 2. All right, the negatives are going to pull us into the negative direction. Good, you got the negative 2x. And negative 3 plus negative 8, same sign. You're going to add them together and keep the sign the same. Awesome. You got it right. So whether you put negative 2x plus negative 11 or negative 2x minus 11, that is the same exact thing. So you would get it correct. Awesome. Woo, woo, woo. All right. Keep those questions coming. Anish, tell your sister to come on. I might be able to help. So if she has a question, you know, we got 20 more minutes here. I'm free. I'm here to help. So if anybody else has any questions, go ahead. You can type it in the comments. Let me know. You're so welcome. Okay, so if you have any questions, type it in the comments. I am here for you? Anything that you want to go over? Okay, she's here. Awesome. Okay, that's fine. Yeah. So if you guys want to remain anonymous, go ahead and just complete the form. You don't have to join me on the live. Just put the question and then I can help you out. If you have a picture of the question, that works too. Okay. Awesome. You guys are doing great. I'm so happy. All these light bulb moments today. Okay. So just a reminder as we wait for the question to come up. This is More Math Homework Help. Welcome, welcome. So if you have any questions, I am here to help you. One problem at a time. And we are here every Wednesday night. There we go. We are here and by we, I mean me. I am here every Wednesday night from 8 to 10 p.m. to help you with your math homework. So drop in anytime between 8 to 10 on Wednesday nights, and I'm here. Also, the form is the same every week. So if you complete that form before I go live, I'll be able to help you a lot better. But if you can only just jump on a live, I'm good too. Okay, but it does help me a lot to see those questions ahead of time so I can come up with different ways to, show you if one way might work better for you. Okay, but that form is right there if you want it. Okay, I see it. Okay, let me grab the question. Finding BEC by angles. Okay. I'm going to pull up the question now. If G is the midpoint, can't classify each triangle by angles inside. Let me see if I can share each screen. All right, I'm going to start off by saying that I'm going to try this. So my forte is algebra, but that's fine. All right. So if G is the midpoint of A and B, classify each triangle by its angle and sides. So they just want you to say if it's like an equilateral triangle or what do you call it? An equilateral triangle or acute and all of that. Just let me know in the chat if that's all they're saying about the classifying it, because classifying can range. All right, so let's start with C, D, and can y'all see that? It's kind of small. Let's see. Let's enlarge it. Okay, so we're just classifying as equilateral now. Okay, we can handle that. C, F, and E. All right, so we do have a right angle. Okay, we have a 2, a 5. Oh, B, yes, I'm sorry. B, E, and C. Sorry about that. Okay. So B, E, and C, let's take a look at this. Okay, so first things first, you're going to need to know, do you have the side length for B and F? Because we have BC and we have CE, the side lengths for those. Okay, so I have a feeling that if you know what the side length for BE is, that's going to help you identify what kind of triangle it is. So right away, I can see, let me see if you can see my, okay. So right away, I can see that BG, let me zoom in a little bit more. Okay, I can see that BG equals 6. Okay, good. BF is 6. Now BE is how much? So if you can see that BF is 6, BE is how much? So BF from B to F is 6. From E to F is what? And then what does that make BE? Awesome. Okay, so BE is 8. And BC is 8. And CE is 5. So if I have two sides that are 8, when I have two sides that are the same, what's that? What do we call that triangle? So B, yes, there we go. Yeah, so it's isosceles. You said by side. Yep, isosceles by sides. Okay, yeah, the angles won't help us here, but it is isosceles. Awesome. You were able to get the other two? 3 and 4. Or did you just get stuck at 2? But yeah, good. And that's great. You actually got the hardest part. BF, it's really hard for students to see that equals 6. So you actually had the hardest part. You just had to add them together. So that means the two base angles. Yes. Okay. And what's the measurement of them if they're equal? Most of the time when they're equal. Oh, gotcha. Okay, did you learn what the angles are usually in a isosceles triangle? Gotcha. Okay, so usually, let me just see. Usually isosceles triangle is 45, 45. But that doesn't look like a right angle. So let's see if we can figure out what the angle is. Now, do they want you to say what the angles are, or do they just want you to, they want you to do acute, or I just realized what they wanted you to do. They just wanted you to say if it's acute, obtuse, or a right triangle. Okay. So if you look at this, I don't see any right angles here, right? I also don't see anything that looks like it could be over 90 degrees. So if you're looking at B, E, and C, they don't look like there's angles that are 90 degrees. And it also doesn't look like anything that's over. No matter how you transform it, there's nothing over 90 degrees. So you can already take out obtuse, and you can already take out a right triangle. And what does that leave you with? Okay, because it's going to be all angles that are under 90 degrees. So what is that going to leave you with? You know what those are called? Okay. Tell me in the comment what it's called. Yeah, well, we know that it's acute. You can eyeball it. Well, first of all, you see how they make it obvious for B, F, and C that it's a right angle. C, F, and E is a right angle as well. So together, that E, angle C, and that's, angle E is going to be a smaller, it's going to be smaller than 90 degrees, okay? Because angle E and that small part of angle C is going to be add up to 90 degrees. So it has to be smaller. And because BE and BC are both equal, the angles opposite it are equal. So angle E and angle C are going to be less than 90 degrees. Okay. And if B was a right angle, there'll be a, the little square. So we're able to see that that is going to be an acute angle. I know they say don't look at the model, but honestly, that's what's going to help us help you if you look at it. But I just showed you how to, prove to your teacher that it is going to be less than 90 degrees. Okay. Do you have any more questions from this one? Let me know. We still have 9 minutes, so I can help you with anything if you need me. You're welcome. What grade are you in? Is this 10th grade? Are you at our school? No problem. That's what I'm here for. And let me know if you need, okay. It's 8th grade. Yeah, I gotcha. So yeah, let me know if you need any other math help. So usually every Wednesday, I'm going to be here from 8 to 10. So if you ever need any math help, let me know. I've gotcha. And, gotcha. My kids are going to be in that course next year. So you're helping me prepare them for it. Yeah, but I'm able to help you out. No worries. I'm glad that helped. You are so welcome. All right. Let me grab the banner. Okay. Good. Wow, we did a lot tonight. We did combining like terms. You too. We did combining like terms. We did adding integers, simplifying expressions, distributive property, solving multi-step equations, and we ended off with some geometry. This is an amazing night. I am so happy that this is this is our first ever homework help. And I love that there were so many aha moments, so many light bulb moments that just made my entire night, because that's the reason I'm doing all this. I know a lot of times math can be confusing, especially when you don't have that one-on-one, a lot of teachers, as a teacher, we try to get to every student as much as we can, with everybody, some people being virtual and some people in school. It's kind of difficult to have that one-on-one attention with the teacher. And so I'm here for you. So if you are ever struggling with math homework, go ahead, hop on, hop off. You don't have to stay the whole time. Come in, get the help you need, and pop right off, okay? So make sure you complete that form. Make sure that you complete the form. If you ever want to join me live, complete the form. Say yes, you want to go live, because it really does help me to be able to help you faster. One, because I don't have to wait for you to type, but it's okay if you just want to chat or type in the chat. But it does help it go a little bit faster when I can get that immediate feedback from you and see what's working, what's not working, what's going to help you, what's not helping you, and so on. So I would encourage you guys to come live with me. You don't have to show your face. You can be anonymous the whole time. Nobody has to know your name. But if I could hear your voice and you can let me know if you are understanding it or not. That's going to be so great. So I'm just so happy that you guys came. For those who came and got the much needed math help, thank you for coming on this live, trusting me to help you with your math homework. I'm so happy that I could help tonight. This really made my night. You guys have no idea how much I love doing this. So that's all we have for tonight. So that's it, y'all. I hope by the end of this, you guys are saying more math. I'll see you next week. Bye.